Sorry.
What? Years ago. Is it supposed to rain today?
No.
There was a chance.
No.
No.
There
No,
was
that's
a
what it said this
chance,
morning.
but it's a very low chance.
Well, it looks like a good chance of getting better. It's windy and cold.
Well, the temperature's supposed to drop like 15 degrees overnight.
15?
It's supposed to be like a low of 42.
What are the game temperatures?
The problem is you're solving for y of n and you have a difference equation of y of n minus 5.
Y, with Y then,
Yes.
minus 5.
Y of n minus 1 plus 6 y of n minus 2. And that's equal to 4 u of n. And in particular, I'm curious about like the result has a component given as minus 16 to the n minus 1, u of n minus 1, and like the way I solved it and the way I'm looking at this.
Well, what is, any initial conditions, Y of minus 1, Y of minus 2?
Yeah.
Give me those values.
Those are both 1.
Y of minus 1 equals Y of minus 2 equals 1.
1.
All right, well, if we're gonna do this, this is a very straight thing. We're just gonna do the Z transform on both sides. And then we're just going to solve for basically Y of Z.
Right.
And then do the inverse of it, all right? So to start off, if we're gonna do that, first I'm gonna take the Z transform of this equation, and you're gonna get Y of Z here, right? Then it's minus 5, right, times quantity. Let me do it this way, 5 times the quantity, and it would be Z to the minus 1 times Y of Z, right? And then it's gonna be plus Y of minus 1. You agree with me so far? Right? Now, keep going, plus 6, quantity 6, then it's gonna be Z to the minus 2, right? Times Y of Z here, right? Then you're gonna have what? Plus, and it's gonna be what? Times Y of, Y of minus 1, right? Plus Y of minus 2, right? Equal, and then the Z transform of U of, it's gonna be 4 times the Z transform of U of n, which is gonna be simply what? Z over Z minus 1, correct, class? You can, if you want to leave it as 1 over 1 minus Z to the minus 1, it's fine too, but I'm gonna leave it in that form. Do you all agree with me there? All right, now the next thing I'm gonna do is just substitute in the values for Y of minus 1, Y of minus 2. And because they're 1, it's easy to do, and then I'm gonna factor everything. Now, let me ask you this. Do you mind if I just erase the Y to minus 1 and Y to minus 2 and put a 1 in there? Everybody okay with that? Because that's the initial conditions, right? I mean, I call them the initial conditions. Those are the conditions just before the start of the event. Right? Are you okay with that? He's writing furiously. Maybe I won't. Maybe I'll just put it down here. I'll go down 1. So I'm going to have Y and Z here minus 5 times Z to the minus 1, Y of Z here, right? Plus 1, plus 6, and it's going to be times Z to the minus 2 times Y of Z, plus Z to the minus 1 times 1, plus 1, all equals 4Z over Z minus 1. Now I've just put in the initial conditions. Now after that, the only thing I'm going to do, I can do this easily. I'm going to take everything that doesn't have a Y of Z in it and put it on this side. Everybody understand why, right? So what am I going to do here? I have minus 5 times 1. When I take it to the other side, it's plus 5. Agreed, class? So the only thing I do is get rid of this, put a plus 5. Is everybody all right with that? Now, the next thing I have is 6 times 1 here, right? When I take it to the other side, it's minus 6, correct, class? So I just erase this. Right? And now,
Don't you need to erase the 5 and the 6?
no, remember, I
Okay,
just
they're
erased the
moving.
term,
Yeah.
they're multiplying, but I just want to make sure everybody sees that, right? Now, y'all know I can combine these to minus 1, correct, class? I'm not working faster, I want to make sure y'all see that. So I'm just going to make this minus 1. Now, the next thing I'm going to do is look for any terms that don't have y of z, that just have z. And I have 1, don't I? I have 6z to the minus 1, don't I? That comes to the other side, it's minus 6z to the minus 1. Agreed? So I just erased that here. Everybody agree with that? Now, this is purely up to you how you want to do it. Now, I'm personally going to factor the y of z out of that equation by itself. When I get y of z by itself here, I have the quantity 1 minus 5 z to the minus 1, and it's going to be plus 6z to the minus 2, right? All equal to, over there is 4z over z minus 1 minus 1 minus 6z to the minus 1 here. And correct me if I've done anything wrong. Are you all right with all that? Now, what I'm going to do is multiply both sides by z squared. The reason is, there's a z to the minus 2 here. Follow me? I want everything in terms of z to the 0 or higher powers. So if I multiply both sides by z squared, keep an eye on me. Then I'm going to get, I'll put it up here. Josh, keep an eye on me on this one. So now I have y of z here times the quantity z squared minus 5z plus 6, correct? Plus 6 equal, and then over here I have 4z over z minus 1 times quantity z squared. I'm going to leave it like that, the front, and then it's going to be minus z squared, and then minus 6z. Do y'all agree with that?
Yep.
Now, that right there, I look at it, I see that I have minus 2 minus 3, z minus 2, z minus 3 should render that. You agree with me, class? So I'm going to go ahead and say this right here can be given as y of z times z minus 2, z minus 3 equal to all this. So I have z squared times 4z, z minus 1, minus z squared minus 6z. And then I simply divide through by the z minus 2, z minus 3 business. Agree? Now, you did all that, didn't you, Josh? All right. So if you've done all that, now you get finally y of z here in the form that we can work with it is equal to z squared times the quantity 4z here over z minus 1 times 1 over z minus 2 times z minus 3, right? And then it's going to be minus z squared over z minus 2, z minus 3, then finally minus 6z over z minus 2, z minus 3. And the only thing I've done now is just got yz by itself. Agreed, class? Now, after that, we have to get the inverse, and this is what you were asking about. So when I look at this right here, I'm going to start back here, right here. You can start back there. All right? Now, if you start there, what are we going to do to get that inverse of that? Don't you divide by z first under the partial fraction expansion? Do you remember this? Matter of fact, why don't I just do this? I'll take y of z by z, I'll do the whole thing right here. We're gonna do y of z by z, that means this becomes simply z, right? This becomes simply z, and that goes away. Now I have y of z by z for the partials. Agree, class? All right, I want to do the last one first. Help me with this one, guys. So I have minus 6 over z minus 2, z minus 3. That equals some c1 over z minus 2 plus c2 over z minus 3. Correct, class? I'm not trying to prolong the agony here. Just make sure everybody sees this. Everybody got that? All right, how do I get c1, please? C1 has a pole at z equals 2, doesn't it? Right? Z equals 2. So you cover up the z, right, the z minus 2, and let z be 2. What do you have? You have 2 minus 3, or minus 1, divided into minus 6, which is 6. Do you agree with me? And I'm going to put it right here. So that's 6. What is C2? Just do it. Cover up the z minus 3, let z be equal to 3, what do we get?
-6.
Minus 6. I bet you most of you kind of know that's coming, by the way. So this is going to be minus 6, right? Agreed? I'm going to leave it that way. I'm not going to multiply it by z yet. Agreed? Go to the next one, which is, what is it?
Z.
Minus z.
Minus z over z minus 2 times z minus 3 equals some c1 over z minus 2 plus c2 over z minus 3. Help me out here. You guys do this one. What is c1? Pole is at z equal 2, right? Cover up the 2, what do you get? Z goes to 2. I have minus 2 divided by minus 1, right? Or
2.
2. Keep going.
So that's
Be
What
minus,
about C2?
minus 3.
Minus 3? Is it minus 3? Good, good. Minus 3. All right. Finally, this one here. Now the nice thing is z squared is the highest power of z upstairs. The highest power of z downstairs is z cubed if you do the multiplier. So it's still proper. Follow me? That means for the last one I have 4 z squared over z minus 1, z minus 2, z minus 3.
Okay, so that one, that's supposed to be a z in the last one we just did, or, I mean, a 2.
Yeah, it's a z here.
Was it?
It's just right over there. Just, I mean, the only thing I've done is trying to recopy it here, the individual things. Now for this one, what is this? We've got 3 on this one, don't we? We have some c1 over z minus 1 plus c2 over z minus 2 plus c3 over z minus 3. And help me out here, what is c1? Is this how you did this, by the way? Didn't you, I mean, I'm trying to do it straightforward. You look for a quicker way? You got a common denominator.
Yeah, I got it.
They don't like that approach. I think you might hurt yourself, but it may work. But I'm gonna do it this way. You just tell me if you, I see where you're going, why you did it, but I like to do it this way. So keep going with, give me C1 in this one.
2.
Pole is at z equals 1, right? Agree? So you cover that up. If it's 1, I have 4 over 1 minus 2 is minus 1, right? And 1 minus 3 is minus 2, right? I have minus 1 minus 2, or 2. 2 into 4 is going to be 2. Do you agree with me? So it's 2. What's the next one, people? What about C2? Pole is at z equal 2. Agree? So if I cover z minus 2 up, right? 2 minus 1 is 1, right? 2 minus 3 is minus 1, right? What happens up here? I got minus 1 into 16, right? Or minus 16. Agreed, class? Did you hear that? Minus 16. That's what you were asking about, I think. I think. Maybe I'm wrong. Did you ask? Did I hear the number 16 initially? Or is it-
Yeah, it's that term that
You all see it right? You see it right there. Josh, here, you do it. You asked about it. Pole's at 2, right? cover up z minus 2. I got 4 times 2 squared is 4 times 4 is 16, right? I think I'm right. Isn't that 16?
Yes, sir.
All right, heck with it. You do it on your own, Josh. It works. How about the last term?
18.
What is it?
18.
Is it 18? I'll take your word for it. Anybody confirm or deny 18 on that one? Well, what do? You cover up what? Z minus 3, right? And you got 4 times 3 squared is what? 4 times 9, right? 36, right? Divided by 2.
That's
Okay.
right.
You're good. I'll give you that. Are we good? Now, all of those have to be multiplied by z before we get the inverse. Do you agree with me? Everybody? Because they divide by z. So I'm going to just do it, I'm going to do the inverse right here. So I multiply them all by z. That's z, that's z, that's z, that's z, that's z, that's z, and that is z. So, what do you get for the top one? I've got 6 times, take a look at this, z over z minus a, right? So that's 2 to the n, right? I know it's going to be all times u of n, so I'm not going to put it in the u of n's yet, right? What about this? Minus 6 times, what? 3 to the n, do you agree with me? That's minus 3 there, correct? Keep going down here, what do we have? Plus 2, right? Times 2 to the n, right? I know the u of n's coming, don't worry, I'm just putting them all out there. Minus 3 times, people? 3 to the n, keep going. Plus, put it down here. 2 times 1 to the n, or just 1, right? Times 2, so just 2's there. Now keep going, what's next, people? Minus 16 times 2 to the n, and finally, to the n, all times u of n. Now, if you want to group things, you're fine, that's the right answer, but I can see I have 2 to the n, and what do I have as far as the coefficient of 2 to the n here? I have 6, right? And I have 2, right? Right, so that's 8, and then I have minus 16 is going to be what? Minus 8, correct? So I'm going to have minus 8 here. And what do we have for 3? I have minus 6, minus 3 is minus 9, correct? And then I have plus 18, or really I'm going to have 9, right? And plus 2, right? And that's all times u of n. Agree, class? Now, does that jive with the book, guys? Josh?
No, and the reason why is because they factored out a z plus 2 instead of a z minus 2, and their like solution is whack. So,
Oh, there's a mistake.
yeah, that's what was tripping me up.
Well, if there's a
I
mistake in
agree
there,
with your solution.
that's the way you do that, though. It's,
Also, another thing they did is instead of factoring out a z before starting it all, they did, the partial fraction, and then as a transform
That
instead
doesn't
of
work.
to the n, it's n minus 1.
no, you, listen, always divide by z.
All right.
Always divide, hear me? Always divide by z. If you don't do that, you get some really silly answers. Now that should, do the first number of theirs. Just take n equals 0. For n equals 0, what do we have? I have minus 8 plus 9, right? So I have 1 plus 2 is 3. So it should be 3 for 0. Do they have 3?
Yes.
All right, now for n equal 1, check the numbers out. If n equals 1, I have what? Minus 8 times 2 is minus 16, right? And then I'm going to have plus what? Plus 27, right? Or plus 11, correct? And then I have plus 2 is
13.
13. Do they have 13?
That's right.
All right, well, this is an easier way to do it,
Okay.
I think. I don't like the n plus 1 stuff left in there. All right, y'all agree with me, class? Now, it's tedious, it takes a little longer to do it that way, because I didn't get one common denominator in just the fact that I did it that way, because it's, to me, it seemed easy to do it that way. But you can if you want. Okay? Any questions about that? That's a good problem, though, because it comes from a difference equation. What else? Questions? Did y'all, y'all get them? Problems? You see, Z transforms are really like Laplace for difference equations, right? Z transforms the difference equation are like Laplace the differential equations, right? With the initial conditions. That's basically it. You're doing partial fraction expansions with the fact there's one difference. You divide by Z instead of that first. And that's basically it. Now, no other questions about those homework I gave you? And y'all did?
I just wanted to ask you, like, if you have like an equation of like a to the n times cosine of some number, where you just have like 1 over 1 minus a, and then z.
Whoa. If you have a to the n cosine of omega naught n, u of n, all right? Gotta be a u of n there. You can do it two ways. You can do it with modulation, right? Or the actual transform for that is given in your pairs. If you take a look at that. They have a to the n cosine of omega naught n as the formal transform, and they kind of group it together. But you can do it with modulation, or you can do it, with modulation, you get 1/2 times what?
Okay, you just do 1/2 times.
It's
the
the
function
transform, the
z.
original transform, then instead of z, it's z times e to the j omega naught, right? And then plus the original transform, but instead of z, it's z times e to the minus j omega naught. That's it. Either one, that works all the time. Question? Josh, did you have another one for me or not?
Well, I didn't like your Fibonacci question.
It's Fibonacci numbers. Don't worry about that one. It's just a bizarre numbering
Yeah.
system.
But other than that,
Nothing. The Fibonacci numbers, they throw that out there because it's very famous.
I got that, I just didn't like it.
Didn't care for the math on that one?
Yeah.
All right, got a few things to cover today. All right, now we're going to go into things where we're talking about how to actually implement difference equations and really transfer functions. What do block diagrams look in the Z domain? Or like in the Z domain, and they're just like what they did with the Laplace transform business. I'm going to just show you this. Remember, if you have any kind of input-output relationship where you're going to have an h of z, which is a transform, the output y of z is just h of z times the input x of z, right? So if you string them together, and I'm only going to put 2, but if you string them together like this, let me say this is h1 of z and this is h2 of z. Then my output here, y of z, would be equal to x of z times h1 of z times h2 of z, if this was x of z. And if you look at this, you could make it one single operator. You could say these two could be replaced by a single operation that is just h1 of z times h2 of z. You all see that? And that would be equivalent to a single transfer function, because they're in series. Does everybody see that, by the way? The far back guys, right? Don't forget this. This is coming at you. So remember that. I could string as many as I want. 1, 2, 3, 4, 100 of them. You just multiply the transfer functions. Understand? That's it. That's in series. Now, if they're in parallel, like this, I'll only do 2. And I'm just going to take, this is x of z, and I'm going to put a summer here. My output here would be simply x of z, and it's times h1 of z, plus x of z times h2 of z, or just h1 of z plus h2 of z. and that would be my y of z. Which means for a sine, and by the way, I can have as many as I want parallel. I show you two, but it could be 3, 4, 5, and if you want to, you could effectively replace both of these two in this summer with a single h function that's just equal to h1 of z plus h2 of z. You all see that? Just like Laplace, right? Y'all know? You see what I'm doing there? You look confused. I mean, you look concerned, not confused, concerned. If it's my writing, I'm sorry. It's as good as it gets. But the next one is the one that people have trouble with, and that's negative feedback. Make sure you notice the signs on this one. This is negative. There is also positive feedback. It's a little different. So with negative feedback, this is for control, basically. When you have an input x of z, it's coming in, and it's coming into a summer. This will be added positive, but this portion will be negative. Then it's going to go through, and there'll be a forward transform. h1 of z. I'm going to leave it as h1 of z here. This is an amplification factor. A lot of times it's just a of z, but I'm leaving it as h1. Then a portion of the output right here is going to be fed back to the input, but it's fed back through negative feedback, and this is going to be h2 of z. Oftentimes it's labeled b or beta of z. It's a feedback portion of signal, and it's going to be fed back negatively. And this output is y of z. Now, it's been a while since we've done this, so I'm going to go through this one, because this is the one that's probably a little less obvious. Y'all remember seeing this with Laplace, right? The easy way to do it is that's y of z, so the signal right here is just going to be h2 of z times y of z. That's what's right there. Do y'all agree with that? Pretty obvious, correct? Now, if that's what the signal is right here, then the signal right here, at that point, is going to be x of z minus h2 of z, right, times y of z. That's the signal at that point. I hope you can all see this, right? Now, the only thing we need to do to get y of z is multiply this signal by h1 of z, and I have y of z. Do you agree with me, class? So, what I can do is this. I can say my y of z here is going to be equal to x of z, right, times the quantity, or sorry, minus y of z times h2 of z here, and then it's times h1 of z, and that's y of z. Agree? And then I'm going to get y of z on one side, so I'm going to have y of z over there. And I'm going to factor out a 1 here, and then I'm going to take this minus y of z, h2 of z, h1 of z to this side, so it's going to be plus h2 of z, h1 of z here. And I'm going to say that whole thing is going to be equal to h1 of z times x of z. Just notice what I've done here. I simply took everything with y on one side, left the other stuff with x on the other, right? There's nothing magical here, it's very obvious. Nothing tricky. Now, I need to get y over x to get the transfer function of the system, right? So now I can say the total transfer function, if we wanted to replace all this stuff by a single block, it would be y of z over x of z. And this is like a single transfer function, like the h of z of the system. And that would be equal to h1 of z, the forward gain, divided by 1 plus the forward gain, h1 of z, times the reverse gain, or times the feedback gain, which is h2 of z. And that's it. That's negative feedback in the z domain. Same as it was with Laplace. Agreed, everyone? Now, and I might add one thing. Y'all see what I've done here so far? I want to show you one slight deviation once you're done with this now. You don't need to write it down, just watch and you'll understand. What if all of a sudden it's positive feedback? Suppose this, instead of negative, the way it normally is, suppose this becomes plus. What happens here? Plus. Right? What happens here? Plus, right? Isn't that right?
Yeah.
Right? Correct, class? Keep watching. And then what happens? Now, when I take this term to the other side, what happens here? Negative, right? And what happens here? Minus. Follow me? The net effect is called positive feedback. This will increase in general, the output magnitude in general. You'll notice that down here, it looks like it's getting smaller instead of larger. Did you follow me on this, class? For any strictly positive values of H1 and H2, yes, sir.
If the input right there is positive, does that mean the X of T would be negative? Or
X of Z?
X of T, yes, sir.
No, I didn't flip that one. I'm saying this is strict positive feedback. This is something that will enhance the output and make it less stable. I'll leave it at that. But I want you to make sure you understand how you could go through that one for positive feedback. Understand, class? And in general, the real value, whether it's positive or negative, has a lot to do with the polarity of these. Because if this has a negative sign in front of it, then this is negative feedback, even though it's got a positive sign. Follow me? So you got to just make sure you know how to do these block diagram problems. I'm going to take this off and put something up there. I'll tell you one thing, where I'm going with this is I'm going to try to draw a parallel to, remember how we used Laplace transforms some time ago, Laplace transform theory, to actually implement transfer function using operational amplifiers, right? How many have seen operational amplifiers? All right, you should have all seen something like that in your classes, but if you haven't, you will. So you have what's called the basic, you have a basic understanding of how to implement a transfer function, any kind of transfer function, an H of S, which is very, very important. You can build circuits to do that now. With Z transforms, that's digital stuff. Now, digital things, or anything like that, I should say discrete time systems, because they have values that are at given points in time, you don't have analog circuit components that you use to build them. You have summers, basically summers and subtractors and multipliers that go ahead and delay lines, where you delay by 1 or 2 time steps. And you can implement anything, and you can do digital filtering. So now, what I'm going to do, well, before I have time to implement some of these designs, but I want to go through an analysis with you, a simple analysis, to make sure you know how to do these things. I'm going to show you a trick about this. You're going to get some problems like this. I'm going to draw a block diagram of it. Suppose I have a block diagram here, and I have a value of 1/2. This is the flow of the signal. And then I'm going to have something where it's a summer here, and it's going to be positive. It's not negative here. I'm going to have a block here that has 1/2. This is the flow of the signal. It's going to come here, and this is going to be a delay, or what they do is normally put a D on here, and I'll explain what that becomes in a second. It's just going to delay the signal, whatever it is here. If this is Y then, this will be Y of n minus 1 coming out. That's the delay line. And then this is the way it's fed back, and here, another summer. Here's my output, Y of n. Here's my input, X of n. Now, here's how you analyze a system like this. This is a summer and it's positive. The feedback is positive sense. Y'all see what I've got here? I've got two summers, I've got a delay line. Delay means the value here will come out with, if this is y then, this is y then minus n minus 1 here. Follow me? It's just delayed by one value of n. Follow me? Now what that is, in terms of a z transform operator, it's just z to the minus 1. So anytime you see a d, you just put z to the minus 1 in. Now we do everything in the z domain. The x of n becomes x of z. Y of n becomes y of z. Listen to me for a second. Now you'll notice the only thing I've done here is I've got one delay line. It simply delays the output value by 1. As a matter of fact, it holds the value going in and lets the previous value come out. Follow me? And all these things will be done with a clock cycle. Not it's going to start doing it. Angle 1, 2, 3, and starts chunking through there. This doesn't look like it's going to implement much, but watch what comes out when we do this. What do we get for y right there? Well, let me just show you the values. What's the value of the signal right there?
1/2 x of z.
That's right, just x. Really, I'll call it x over 2 right there. I'm going to leave it as just x over 2. Do you all agree with that? Now, follow me on this too. Right here, this system, that's positive feedback, isn't it? You'll notice the forward gain is z to the minus 1, right? The reverse gain is 1/2, correct, class? So if it's positive feedback, I can snip this here and here, and I'm about out of time, and I can replace that just with z to the minus 1 over the quantity 1 minus 1/2 z to the minus 1. Do you see that? Just look at your notes. How many see this right here? Y'all recognize the forward gain here is z to the minus 1. That would be my h1 of z in the prior thing. The reverse gain is 1/2, right? But instead of negative, it's positive feedback. Isn't it, class? So just watch this. I'm going to erase this. I can take that whole thing, which is nice, and I can replace it by this. A single block that has the form forward gain is z to the minus 1 over 1 minus 1/2 z to the minus 1 here. And that, please look at your notes on this one, can replace it. Do y'all see that, class? Now, y'all agree that I can multiply top and bottom by z? And if I do that, now I get what? 1 over z minus 1/2, don't I? Right? And then I can say really what I've got here. I'm just going to leave it like that. Now, can you all follow me on this one? What is the signal right here? It's 1/2 times x of n times 1 over z minus 1/2 right there, right? I add to it x of z here, that's y of z. You all see how easy it is when you replace that feedback system by a single block? That's my goal today. Are you with me? How many see it? I'll give you homework on this one. You're going to see where we're going with this. We're actually going to be building digital system filters, you might say. I'm not going to take it at the level Dr. Reeves will, but it's going to at least introduce you to the idea and the power of these things. All right, you have a quiz today. Do me a favor. Separate yourself by 2 desks and try to go every other row.